As many of you may know, our tropics have been pretty quiet this year. It was forecast for a while that we'd be seeing a really active season, and for the most part, all we've had is Hurricane Beryl back in, I believe, January or February, pretty early in the season. Otherwise, we've had nothing really going on. The season's been warming up, but now we have Tropical Storm Francine, who is trying to shake that up. Welcome back to another video, everyone. I'm gonna be looking at Tropical Storm Francine. I am not too well versed in hurricanes, but I'll be looking at what's really pushing this storm, and also what are the kind of flies in the ointment. What's the issues with this storm as well? So first of all, it's probably important to look here at the what we've seen. This is our College 2 page satellite radar, and it's very useful for really tropical systems too. Honestly, it's useful for all sorts of things. So this is from this yesterday night. This is 8Z today, which is at 2 p.m. Central Time. Or sorry, 1 p.m. Or sorry, excuse me, 3 p.m. Central Time. 3 a.m. Central Time. Oh my goodness. 3 a.m. Central Time. Excuse my failure to convert my hours. 3 a.m. Central Time, we had convection kind of ongoing here. You can see very, very powerful convection. These cloud tops are very, very cold. And essentially, this was just kind of off the coast here. And for a while, this has been the NHC has been tracking this system and slowly increasing the probability that it actually forms and turns into something. Here you can see just very heavy convection for most of the day, right around, this is 9 a.m. And as the day went on, right around here near noon, this convection kind of slowed down, was not as strong. You can see it kind of see a little bit of clearing out along the back, and these inner bands also seen much stronger. See in the visible radar here, something similar. Here's nighttime. So right after nighttime, you can see a bunch of convection, just a huge cloud tops, very cold. And as you can see that rotation all of a sudden right after that. You can see that along that backside, you can see that rotation. And this thing is really starting to pick up intensity as it's really getting that low pressure. It's really starting to create that low pressure. I'm not quite sure on the millibars what's the real what the pressure of this system is at the moment. It's probably on one of the websites here, but I'm not too well versed in hurricane stuff quite yet. So I don't really know where to find this information at the moment. But what we do know is that this is it's most likely to strengthen into a hurricane. This morning they called it a tropical storm, and you can see on this cone in basically overnight this will become a hurricane. Already, they already have tropical storm warnings along some of the Texas and Mexican coasts. And then Louisiana there is shown to have a hurricane warning already as well. That's making landfall somewhere around Wednesday, maybe a little bit earlier, but it should happen on Wednesday. The question is, will this end up being a strong hurricane? Will it be a major hurricane? What I'm seeing here is likely not. So here's a different website I've been shown by one of my professors. This is, I don't know who really owns this, but I'm assuming it's the Wisconsin uh, college in Wisconsin. But what this will show us, you can get upper level winds, lower level winds, all these options you see here. But what's most important for us is going to be wind shear. And looking where our system is kind of right here, it's a bad sector, but I'll circle it. The tropical storm is right around in this vicinity at the moment. This will be going into, honestly, quite a bit of shear, according to this. So I can zoom in as well. Oh, perfect. Okay. So there's about where our storm is. This is currently moving into shear. And you can also see this in our cloud tops and our temperatures. You can see any storms that kind of form in these outer bands. These are being sent right to the east. You're not getting any real good west movement at the moment, other than right near that hurricanes or the tropical storm center. This will very soon be a hurricane, by the way. I believe this is happening overnight. So this is currently strengthening as we speak. The Gulf temperatures are very warm this time of year, and we also have a few other disturbances. I believe they're currently watching out there. Yeah, two other disturbances out here. 7-day outlook. Both of them are pretty high chances of development, especially this disturbance 2 over here. I can look at that at a different time. Right now, I'm more worried about Francine, though. Yeah, you can see on this, again, the shear is most certainly very prevalent along this corridor, and the only real area of good vorticity for this storm to go into is going to be right here, right where it's close to it. The question is also, though, where will our shear go? So right now, it doesn't look like there's a bunch, but if you combine everything together, 250 millibar wind speeds, there is definitely some shear. And don't forget, these storms are going very high into the atmosphere, so this will take into account, where the storm is very important in regards to this as well. This is also a huge reason why the storm is being pulled northward, albeit very slowly. We can see here we have a pretty well defined ridge, not very strong, so it's not allowing much shear, but there is a ridge slowly kind of pushing this to the north. The surface map, I don't know if this is really there. It doesn't seem to be, but what seems to be pushing this storm is this ridge right here. Not to mention there is, again, that troughing and the higher levels up here. So there's less air here, and this storm will want to move towards it. So low pressure, it's the pressure gradient force. Higher pressure wants to move to low pressure, and that's just how the atmosphere works. It's a very vital part of just how our weather works. 700 millibars. Again, this is besides 250. There's not much shear beyond that, so that's part of the reason why it's thriving at the moment. But if we get, it could really struggle with this shear if it tries to strengthen, just with how close this is to where the storm is expected to go. There's also the GFS model, by the way, so this very strong intensification that you see here is probably not very likely. I would not take the GFS too seriously all the time. There is rapid intensification being forecast. Sorry, people were beeping a lot outside. There is very rapid intensification being forecast, but the route model here is probably better, better model to look at here. We're on 990 millibars right there, right around the time of landfall. I think it would have landfall right there. About 7 p.m. Wednesday, which was originally what they had. So yeah, an interesting system in that regard. I think it's most important though is the fact to remember there is this shear, and while that doesn't mean the storm can't become major, it just will be struggling with that shear. During severe weather, again, this will have a tornado threat with it, as does most of the tropical systems within the United States. You see there's the 5%. This is for tornadoes. This will also be for tornadoes. You can only see tornadoes right there. They won't talk much about it, but again, they're talking, hey, there's SRH, there's very strong spin in the atmosphere and vorticity. That's just where that's basically coming. Looking further in the future as well, we're, again, staying pretty quiet. We've been pretty quiet for the past few weeks. I mean, even say the past few months. The models kind of disagree what happens after hurricane, or the hurricane, which will be a hurricane after that happens. But what seems to be interesting, I've noticed, is that a lot of the models here are agreeing we get this high pressure ridge up here, kind of in Ontario near Michigan, this vicinity right here near the Great Lakes. But this can help to keep the rest of the depression away from just going right back into the jet stream, as most hurricanes do. We're used to seeing a hurricane kind of form down here, and then it goes up like this because there's a trough like such. This pulls both of them together, and then that hurricane just kind of becomes like a short wave. What was the hurricane becomes basically a short wave in the flow. In this case, though, the GFS ensemble, so basically it's just a bunch of different models are agreeing that what becomes the tropical depression afterwards, will kind of just sit over the Missouri region. The GFS has this, the European model has this. The Euro just kind of keeps us here for a while until this larger scale low pressure trough here in the future will come through. That is also being forecast by the ensemble GFS. Past that is a little bit iffy, but we are going to see this troughing come into place right there on Monday night into Tuesday morning. So that is something to take into account as well. But the specifics of this right now are not important. Don't forget though. Again, these big old large amplitude troughs, that's often a reason for severe weather. I would go into the other these other disturbances, but I don't know enough about tropical stuff, and I don't think it's correct for me to make a forecast on those. So check out the NHC page; they have information which I'm also trying to read up on. Tropical weather discussion is interesting, gives us more specifics as well, and honestly, it's a good place to learn. So takeaways from this video are going to be that Francine is moving into higher shear, and that could be painful for its development. But if it's able to stay in this area of low shear, it definitely could strengthen pretty quickly. Right now, I believe it is forecast to hit as a category 1. Let me find this website. Go back here. The track is showing, category 2. So the models have been showing this intensifying to category 2. Other than that, there's kind of that middle point. Will it hit category 3 and become major? Will it not hit category 3? That's still in the air. But most likely this will fairly quickly be sheared out. You can see right here, as this thing starts to speed up, it will immediately go into just worse air or worse temperatures, not as much moisture. That can be pretty painful for the system. So other than that, that's about all I have to say. Again, check out pages if you want. I'll be keeping an eye on this. Might have a community post out. But with that, thank you for watching, and I'll see you next time.